Monroe Township, New Jersey. Here in this table, I have various metrics available such as area, bedroom, age, and these are the factors that the ultimate price depends on. In the previous tutorial, we looked at simple linear regression with one variable where price was dependent only on area, but now we are making our problem a little more complex by adding bedrooms and age, because as we know in normal life, the home price depends on multiple factors, not just the square foot area. After we build a model, we are going to predict prices of these two homes. Okay. Now, before we tackle any machine learning problem, the first thing that needs to be done is we need to carefully analyze our data set or our training data. When I look at this data set, the first thing I notice is there is a data point missing here. So we have to do something to handle this missing data point. Another thing that I notice is there is a linear relationship between each of these factors and our target variable, which is price. For example, as the home gets older, the price tends to go down. Here I have 3,200 square feet home with 18 years of age, and the price is more than 600,000. Whereas I have a little bigger home here, 3,600 square feet, but since the age is more, the price is less than the one whose square foot area is less. Okay. Similarly, as the area and number of bedrooms goes up, the price also tend to go up. So overall, by analysis, we can say that for this data set, we can use linear regression safely. Okay. If we go into a math a little bit, then our linear equation will look something like this, where price is dependent on three factors: area, bedroom, age, and these three factors are called independent variables or features. Features is a term that you will hear often while going through machine learning material. It is nothing but an independent variable, and the price is a dependent variable. M1, M2, and M3 are called coefficients, and B is an intercept. It can be generalized into this equation where you can have n number of independent variables. I just have 3 here, but you can have more than 3. Now the topics that we are going to cover during this tutorial is, first we'll look into how to handle that missing data point, and then we'll build a model in a Python code. All right, now let's go back to our Jupyter notebook. So Jupyter notebook is something I'm using to write my code. You can use pycharm or any other IDE of your choice. I have a CSV file here where I have all my home prices along with these factors. So the first thing I have done here is imported necessary modules, and then I'm going to load my data into Pandas data frame, home prices.csv. If you don't know about Pandas data frame, then I have a separate Pandas tutorial. Pandas is extremely useful while doing machine learning, so I highly recommend that if you don't know about it already. Okay, so now I have my data frame ready, and I can see this null data point, and I need to handle it. So the way I'm thinking I will handle this is I will take a median of this entire column and put it here. Since number of bedrooms are missing, taking median seems like a safe assumption. All right, so first thing I will do here is calculate the median. And how do you calculate the median of bedrooms? So df.bedrooms will give you Pandas series, and when you do this, it gives you a median. Now you have 3 bedrooms appearing 2 times, that's why it's giving the average of it, which is 3.5. I just want to keep it integer, the whole number, and for that I will just import a math module, and I will say median bedrooms is equal to math.floor and the median bedrooms would be 3. Okay, and the way I fill this column's NA values is using fill NA function. So fill NA function is available on Pandas series. So df.bedrooms will give you one column, which is nothing but a Pandas series. On that, I call fill NA function, and I want to fill all NA values with this median number. So you can see that I got a new series where this NaN value is now replaced with a median number. I need to assign this back to original series so that my data frame gets updated. And when I print my data frame, I can see my data frame looks much better. So our data pre-processing step is over. So again, to summarize, before applying any machine learning model, you need to pre-process your data. You need to clean your data because data is always messy. There are problems with it. So you need to fix the errors, kind of prepare your data, and then apply your actual machine learning model. Using that data, you train the model. Okay. So now my data frame looks good. I am all set to train my model. So the first thing I'm going to do is create a linear regression object. So I have imported linear model here, and using this I will create linear regression class object. The object got created fine. Now I will call fit method. So you will use this fit method often, and this method is used to train your model using your training set. Here my training set is a data frame. So if you want to create a data frame using your existing data frame, you can use this syntax of using two brackets. Okay, and my independent variables are area, bedrooms, and age, and my target variable is price. When I execute this, my model is now ready. Once it is ready, it's a good idea to take a look at the coefficients. So the coefficients I got was this. Just to summarize what these coefficients are, in this equation, M1, M2, and M3 are coefficients. So this is M1, this is M2, and this is M3. Now you'll wonder, where is my intercept? Intercept is stored in another variable called intercept. So this number is this B. So once you have M1, M2, M3, you have area, bedrooms, age, which are your independent variable. Now you can calculate the price. So here I can say predict. Okay, so I can predict a home price of a home whose dimensions are this. So 3,000 square foot, 3-bedroom, and 40-year-old. Okay, so 3,000, 3, and 40. That's what I'm going to supply here. 3,000, 3, and 40. And okay, so 3,000 square foot, 3-bedroom, 40-year-old, and I find the price to be this much. All right, so this home is, you can see that the price, so the price of the 3,000 square foot home here is 565,000, but here you got it much less, and the reason is, I think, mainly age. So here it is like 40-year-old versus this home is 15-year-old. Okay, so if I make it 15 year, I will get around it is little bit skewed, but you get the ballpark number. All right, so the price is this, and now I want to know how it calculated this price. So it is coefficient, okay, coefficient multiplied by your square foot plus another coefficient multiplied by your bedrooms, the third coefficient multiplied by the age. Here it is missing an intercept, so we need to add intercept also. So plus intercept, and when you do that, you get that price right here. Because of rounding factor, it's not showing the full value, but it is essentially the same price. Similarly, you can predict the price of the home where the values of those factors is 2500, 4 and 5. 2500, 4 bedroom, only 5-year-old. This home is very new, so I expect the price to be little higher than average. So here you can see that $588,000 is the price. For this home, which was 2600, the price was 550, but this home's price is more, and it is because this home was 20-year-old, whereas this home is only 5-year-old, and it has one more bedroom. See, this guy had only 3 bedrooms. So you can see how different factors play a significant role. Okay, that's all I had. Now we are going to do an exercise. So the exercise is for you guys to practice what you have learned in this tutorial. I have this CSV file which contains hiring data for a firm. Here, based on the experience, the written test score, and the personal interview score, candidate salary is decided. And I have some past data. Using this data, you have to build a model for your HR department where they can feed in experience and various scores, and they can get some idea on what kind of salary they need to offer to a candidate. Now in this data set, you will find few interesting things. First of all, in experience, these two cells don't have values, so you can just assume them to be 0. Here also there is one data point missing. Here you shouldn't assume it to be 0. Maybe take a median here, all right? And also, usually linear regression models work on numbers, whereas here I have a string. So the experience, again, it's a number. It's just that our data set contains word for that particular number. For this, you can use Python's word to number module to convert that string into a number. All right, so just do pip install and use the module. All right, and using this, what you're going to do is figure out the salary for 2 candidates who has these statistics. So one candidate has 2 years experience, scored 9 and 6 in 2 tests. Second candidate, an excellent guy, 12 years experience, scored 10 out of 10 in both of it. And you have to find out recommended salary for these 2 candidates. If you go to my GitHub page, let me go to my GitHub page. I have all the tutorials available on my GitHub, so you should go and download it. So here, this notebook is whatever I just went through. And in the exercise folder, I have a CSV file, which you should download and try to practice on your own. And then you can compare your answer to this notebook where I have provided the entire solution. But